Objective 1 is to understand agriculture producers' climate information uses to improve climate change communication gaps between scientific communities and agriculture producers. To do that, I will identify climate data sources, formats, types, and accesses preferred by agriculture producers for information farm decisions and understand how producers comprehend climate information in cartographic methods. The theory for the theoretical framework elaboration likelihood model to find the differences between high involvements and low involvements group to use climate information. The design interview research used a non-random sample. I recruited agriculture producers through agriculture research extension centers who were willing to spend half an hour and 1 hour for my interview. The first two sets of the questions were structured to get an overview of the agriculture producer's demographic and farm operation information. The last sets of questions were more unstructured and open-ended to examine how agriculture producers interpret and visualize climate information in their decision-making, and to determine what factors enable or hinder this process. Here, I put weather data to ask because I'm not sure because the previous literature mentioned that weather data are more salient and used by the producers, and the weather data producers can use for daily farm activities. However, for climate data, a use by producers is not fully explored. So, I'm not sure whether I can get more information on the climate data about the formats and the sources where the producers get. And previous study always combine weather and climate data together in their surveys and interviews. A total of 30 in-depth interviews were conducted in 2015 between May to December. Informed consent was obtained from each interview participant, and all interview data collected remained strictly confidential. Anonymity of the respondents was maintained, and interviews were audio recorded and transcribed. I used simple descriptive statistic methods to analyze my interview data. Preliminary interview results show that most of the producers shared more weather use information than climate information, and they tended to spend more time and effort to share their life and farm experiences, since weather data impacts their day-to-day lives. Producers access climate information from different sources. They preferred easy, comprehensive formats like simple icons and maps. Most of them access raw climate data, and some of the producers expressed the potential use of agroclimate indices. Producers access climate information mainly from the internet. Interviews provide qualitative information of climate data uses. However, one limitation of the interview research is that participants were mainly from the northeast and southwest area of Kansas, which does not represent the views of the entire state and their climate consumption information. So survey study was suggested for a better understanding of the spatial variation of the climate data use. Interview results on climate data use and the climate cartographic visualization methods were used to generate a survey to gather data use opinions from agricultural producers. Questions are designed to gather producers' demographic information, including their counties or county they farm. A scoring system is designed using a Likert scale from 1 to 5, 1 being never used at all, 2 not useful, 3 little bit useful, 4 useful, 5 very useful, for climate data sources, formats, types, and accesses. The data formats are accessed through several principles of climate cartographic design, including principles concerning maps layout, focus, visual hierarchy, visual variables, position, size, color value, texture, color hue, orientation, and shape. The survey link will be advertised through Kansas Agronomy Department e-updates, email listserv, and postcards. Informed consent will be obtained from each survey participant digitally. A survey will be conducted using Kansas State Survey Service powered by Quantrix. Interview Internet World Statistics show that 78% of Internet users out of the total population. An institutional board review board application was submitted to the Kansas State University Research Compliances Office in April 2016 for this survey. According to Kansas Farm Facts, there were 61,800 farms in 2003. In order to have a confidential level of 95% at 5 confidence interval, and the survey sample size needs 385 respondents. All survey data collected will remain strictly confidential. Survey data will be analyzed using our open source statistical package. Analysis of variance will also be used to analyze the survey data, testing the spatial and temporal differences that exist among producers for climate data use within the Kansas Statistical District. The outcomes of the survey will indicate data use preferences across Kansas to provide data and visualization designing for the application. The goal of Objective 2 is to develop a climate decision support system based on the previous data use preference research. I will use the climatology network data import into GeoDatabase and then finish the dynamic analysis with modeling and mapping application. Two communication theories are guided for this application design. Anticipated results in Kansas agroclimate website. Framing theory will be used to support the communication text and value based on cartographic design principles. A clear visual hierarchy, simplicity, legibility, consistency, accessibility, and good composition. Framing data can translate the science through scientific data visualization, cognitive, and cartographic design principles. making the visible process of the changing climate visible while rendering the abstract concrete. I will tie into the survey results from Objective 1 to provide climate data and its visual products to meet the needs for agricultural producers. Visual communication messages should be simple, noticeable, understandable, memorable, and emotionally charged, with framing as a means of making sense of issues. Based on that, a second communication theory is applied using construct level theory. It is a theory in social psychology that describes the relationship between psychological distance and the extent to which people's thinking about objects and events is abstract or concrete. This theory is adopted in this research to understand what the perceived psychological distance influences construct level for climate information through geovisualization methods at spatial, temporal, social, and hypothetical levels. It also targets spreading climate information with scientifically accurate visualization and cartographic interpretations that connects the dots from changes in farm-level weather patterns, environmental conditions, and extreme weather events to climate change, as well as successful adaptation strategies among agriculture communities that have already implemented solutions. All datasets will be made publicly available online through the Kansas State University maintained Geographic Information System Spatial Analysis Laboratory (GISSL) websites, and as a cooperative with the Kansas Office of the State Climatologist. Objective 3 is designed to evaluate the climate data visualization methods and geospatial climate support decision-making system. Two criteria are selected. The first one is Foch and Bolt 2004 application usability and effectiveness and the IPCC 2012 special report evaluation rubric. Evaluation workshops lasting 2 to 3 hours will be held in the Kansas Research and Extension Centers using a multimedia PowerPoint presentation with the application and products. Evaluation methods will be used to determine changes in participants' attitudes and knowledge due to the presentations and producers' opinion on the process. Mixed methods with thematic analysis will be used. The anticipated results is for climate data use and climate literacy improvements among agricultural producers. Evaluation workshops lasting 2 to 3 hours will be held in the Kansas Research Extension Centers using a multimedia PowerPoint presentation with the application and products. Workshop will be audio recorded and transcribed and will be analyzed systematically. Evaluation method is to use standard social science assessment techniques. For example, pre- and post-survey, written questionnaire, written qualitative comments, and participant observations. Through the workshop, I hope to get application feedbacks, improvements, questions. Questionnaire survey will be designed for the workshop participants. It will comprise two almost identical sections. The first section, part 1, will be completed before the workshop, and the second section, part 2, will be completed immediately after the workshop.